Assalamualaikum and hi, my name is Nuraisyah Nazri and my magnetic number is F1042. So this is our project design. So the perspective is double story school building and the facilities which is classroom, office, library, toilet and corridors. So our location is at Jalan Baru Serkam, Merlimau, Jasin, Melaka.
So next, for structural plan, here's our roof plan, first floor plan, ground floor plan and pad footing. Next, here also our elevation plan.
Assalamualaikum, my name is Siti Hidayah, number matrix F1007. Next, design specification. Type of building, double story school building, simple skulptur. Address, persimpangan Jalan Baru Sempang, Lemau, Jasin, Melaka. Design working life 50 years, typical recommended design working life for the most building. Expo style SC3, fire resistant, 16 minute or R16. Material strength, concrete C25 per 30 FCK 30 mm square. Reinforcement steel FYK 500 N per millimeter square.
Assalamualaikum, my name is Syahira Nazira Minta Abzaniza. My metric number is F1010. So for the introduction, reinforced concrete design introduce the fundamental of designing and analyzing reinforced concrete structure that combine the strength of concrete, strong in compression, and steel reinforcement, strong in tension, to form a durable and efficient composite material. The course emphasize the use of the limit state design method based on standard of Eurocode 2, focusing on the design of key structural elements such as beams, slab, column and footings. Its main objective is to equip students with the knowledge and skill to design safe, practical and economical reinforced concrete structure in accordance with engineering codes and practice. So next, for two-way restraint slab, the first one is type of slab and support condition. This is a two-way restraint slab because the ratio of the long span to the short span is less than 2. The slab is a case 5, which is meaning to adjacent edge are discontinuous. So the load is shared in both direction but with different stiffness at the support. The second one is key design parameter. Slab thickness is 180 mm. Bar diameter is 10 mm. And the next one is concrete grade is 30, steel strength is 500, and the concrete cover is 35 mm. Load use includes permanent load, variable load, and design load. And the third one is a moment result. Moment developed in both directions according to the restraint condition. In the x direction, the moment around 17.09 kilonewton meter per meter and 22.54 kilonewton meter per meter. In the y direction, the moment is 12.36 kilonewton meter per meter. So for the shear check, shear demand is about 29.69 kilonewton per meter, and the shear capacity is 69.89 kilonewton. Capacity is higher than demand, so shear is safe. For the deflection checking, the actual span to depth ratio is 42.86, which is the allowable span to depth ratio is 72.20. Actual value is smaller than allowable, so the deflection is fast and safe. The sixth one is cracking check. Actual crack value is 300 mm. Allowable limit is 450 mm. Since the actual value is lower, crack width is acceptable. The next one is reinforcement detailing. Long span. Main reinforcement 10 mm bar at 300 mm spacing, and the secondary reinforcement 10 mm bar at 300 mm spacing. For the short span, main reinforcement 10mm bar at 250mm spacing, and the support reinforcement is 10mm bar at 175mm spacing. So for the secondary reinforcement, 10mm at 300mm spacing. So overall, for the conclusion, all check including moment, shear, deflection and cracking are within limits. Reinforcement arrangement follow the behavior of the slab and the edge condition, so the design is safe and structurally efficient.
So this is the second type of slab and support condition. This is two-way resistance slab because the span ratio Ly divided by Ls is less than 2. So the three edges are discontinuous and one edges is continuous, which control how the moment is distributed. So the second one is the main design parameter slab. Slab thickness is 180mm, reinforcement diameter is 10mm, concrete grade is 30, and steel yield strength is 500. So then, these values are suitable for structural slab design. So the third one is the moment result. The slab carries load in both the x direction and y direction. So the moment in x direction, case 1 is 13.34 kN per meter, and case 2 is 17.6 kN per meter. So moment in y direction, case 1 is 7.93 kN per meter, and case 2 is 11.61 kN per meter. So this result reflect the restraint each condition. So for shear check, so shear demand is 22.83 kN per meter, and then the shear capacity is 101.40 kN, and then the shear capacity is higher than shear demand, so the slab is safe. So the fifth is deflection check, which is the actual span to depth ratio is 32.14. The allowable ratio is 60.40, so the actual value is smaller than the allowable value, so the deflection is safe. So cracking check, actual crack width is 300mm, and then the allowable crack width is 450mm. Actual crack width is lower than the allowable value, so cracking is within the limit. So the reinforcement detailing is long span main reinforcement is 10mm bar at 300mm spacing, and the secondary reinforcement is 10mm bar at 300mm spacing. So the short span main reinforcement is 10mm bar at 300mm spacing, and then the support reinforcement is 10mm bar at 250mm spacing. So the secondary reinforcement 10mm bar at 300mm spacing. The overall conclusion, all check moment, shear, deflection and cracking are within the required limit. So the reinforcement layout follow the load distribution and support condition, ensuring the slab is structurally safe and efficient. That's all. Thank you.
I will present the design of simple supported beam reticulum based on the calculation and detailing. First, beam information and specification. For the beam specification, the beam is designed as an EF1 simple supported beam with dimension of 250mm and by 700mm. The main reinforcement is 230mm bar. The concrete grade applied is 30 N per millimeter square, and the reinforcement still used in grade 500 N per millimeter square. The permanent load and variable load are considered, giving a total design load of 3.61 kN per m square. From the calculation, the design moment obtained is 352.35 kNm, and the design with surface is 156.60 kN. The required reinforcement area for bending as required is 2050 mm square. Next, deflection and cracking check. In the structure confirm check, for deflection, the actually span to the depth ratio is 1410, which makes the allowable limit of 14.0. so the beam pass the deflection requirement and will not experience excess sagging. For the cracking check, the actual crack spacing is 50 mm, which is for below the allowable 500 mm. This means the beam has very good crack control and is safe under service load condition. Last, beam detailing. In the detailing section, the beam length is 9,000 mm. The main reinforcement consists of 8 H20 bar at the bottom and 2 H16 bar at the top. For shear reinforcement, H10 500 links are provided. This reinforcement ensures the beam and safely resists both bending and shear force. In conclusion, the design of this simple supported rectangular beam is structurally safe and complete with the design standard. The beam successfully meets all criteria for bending, shear, deflection, and cracking. The reinforcement provides 8 H30, 2 H16, and H10 500 links accurately meets the required structural capacity. Overall, the beam is stable, durable, and suitable for use in building construction.
Assalamualaikum and hi, my name is Zulakimi Bezukifli and my matrix is F1004. For this session, I am presenting the design and detailing of a non-cylinder column located at grade E/1. The column has a size of 140 mm by 250 mm and use 12 mm diameter reinforcement bars. The materials used include grade 30 concrete with a steel yield strength of 500 Newton square millimeters and a concrete cover of 35 millimeters. This column is designed to carry an axial force of 41 kN with a bottom moment of 70.77 kN and a top moment of 5.454 kN. The design moment is 6.01 kN and the required reinforcement area is 70 square millimeters, which corresponds to 4 bars of H12. In terms of detailing, the column uses 4 H12 as a main reinforcement and H6 links spaced at 140 millimeters and 240 millimeters depending on the zone. The detailing drawing on the right shows the complete reinforcement arranged along with the column's clear height. In conclusion, the non-cylinder column is structurally adequate under the applied axial force and bending moment, fulfilling all safety and design requirements. The axial load of 51 kN and the moment demand and safely resisted with the provided reinforcement of 4 H12 main bars, which exceeds the minimal steel requirement. The use of H6 link at 240 mm and 115 mm spacing ensure proper confinement, stability, and resistance against buckling. With the correct detailing and material properties, the column is safe, stable, and fully compliant with a design code provisions. That's all from me. Thank you.